How do you use Charles's gas law? Well, first, what is Charles's law? Charles's law states that V1 over T1 equals V2 over T2, aka volume 1 over temperature 1 equals volume 2 over temperature 2. Another way of writing this is volume 1 times temperature 2 equals volume 2 times temperature 1. Keep in mind that when dealing with temperature, we must input values only in Kelvin. So if we're given a value in Celsius, we must add 273.15 to go from Celsius to Kelvin. So let's look at a problem. Fluorine gas at 300 Kelvin occupies a volume of 500 milliliters. To what temperature should it be lowered to bring the volume to 300 milliliters? So in this problem, we're provided with volume 1, temperature 1, and volume 2. So we can plug these values into Charles's law. And so you have 500 milliliters times X Kelvin equals 300 milliliters times 300 Kelvin. We can now divide both sides by 500 milliliters to solve for temperature 2. And so now, to find the amount of Kelvin for temperature 2, we take 300 milliliters, multiply it by 300 Kelvin, and divide it by 500 milliliters. And we get 180 Kelvin. Let's take a look at another problem. A sample of nitrogen occupies a volume of 575 milliliters at 43.5 degrees Celsius. What volume will it occupy at 90 degrees Celsius? So for this problem, we're provided with temperature 1, volume 1, and temperature 2. So we can plug these values into Charles's law. And so we have 575 milliliters over temperature 1, which we are converting to Kelvin by adding 273.15, equals X milliliters over temperature 2, which we're also converting to Kelvin. We can multiply both sides by temperature 2 to solve for X milliliters. And so we have 575 milliliters multiplied by 363.15 Kelvin over 316.65 Kelvin. And we get about 659.44 milliliters. Let's take a look at another problem. A sample of argon is cooled and its volume went from 1.4 liters to 0.85 liters. If its final temperature was negative 55 degrees Celsius, what was its original temperature in Celsius? So we are provided with volume 1, volume 2, and temperature 2, since this is the final temperature. We can now plug these values into Charles's law. And so we have 1.4 liters multiplied by temperature 2, which we convert to Kelvin by adding 273.15, equals 0.85 liters times X Kelvin. We can divide both sides by 0.85 liters to solve for temperature 1. And so we have 1.4 liters multiplied by 218.15 Kelvin over 0.85 liters. And we get about 359.31 Kelvin. But we're not quite done. The problem asks for the original temperature in Celsius, meaning that we need to convert this back from Kelvin to Celsius. We can do this by subtracting 273.15. And we get about 86.16 degrees Celsius. Let's take a look at one last problem. Hydrogen gas was cooled from 150 Celsius to 50 Celsius. Its new volume is 75 milliliters. What was its original volume? So in this problem, we're provided with temperature 1, temperature 2, and volume 2. We can plug these values into Charles's law to solve for volume 1. And so we have X milliliters over temperature 1 equals 75 milliliters over temperature 2. Remember to convert to Kelvin before plugging in your values for temperature. And so you have 75 milliliters multiplied by 423.15 Kelvin over 323.15 Kelvin. And we get about 98.21 milliliters. Thanks for watching. Like and subscribe.